All right, the next section that we're going to look at is A.3. This is going to be a review of linear equations and functions. So notice we're talking a lot about linear equations in this module. All right, we want to go ahead and review some of our equations, our formulas, and our forms pertaining to linear equations. We've already talked a little bit about formula for slope. And so remember that slope is y2 minus y1 over x2 minus x1, given 2 points on the line x1, y1, and x2, y2. Remember, graphically, we want to think of this as rise over run, the change in the y's over the change in the x's. Now, with linear equations, we have several forms. And the main difference between a formula and a form is when we plug numbers into formulas, we get an answer, we get a number. Forms, on the other hand, are ways to write equations, but just written differently. So the first one that we have is general form. General form is ax plus by equals c. This is usually going to be the start of a problem. Quite often we write problems in general form, and then we are asked to rewrite in slope-intercept form. General form is also a good form if we want to graph using intercepts. Remember, to find intercepts, we plug in 0 for x, we plug in 0 for y, and we solve for each variable. And here, if we plug in 0 for x, our x term goes away, and we just have to divide by the coefficient of y. And if we plug in 0 for y, our y term goes away, and to find x, we just have to divide by the coefficient for x. The next one we have is point slope form, which is y minus y1 equals m times x minus x1. This is a form that we use if we are given a slope and any point other than the y-intercept that is on the line. This is a working form, meaning that we never report our final answer in this form. We use this when we're given situations, when we're given information, and we want to find an equation that satisfies a set of conditions. Again, final answers will never be reported in point-slope form. We will want to translate to slope-intercept form. In order to do that, we distribute the slope, and then we subtract the number that's with the y from the left side to the right. And finally, our last form we have is slope-intercept form. We've already talked about this one quite a bit. This is the one that we like for our final answer. It tells us the slope, and it tells us the y-intercept. As mentioned, our final answers, we want to write them in this form. This is the one, notice that we have our y isolated, which means that we can rewrite in function notation. And for graphing, this is one of the easiest forms to work with. We just have to plot the y-intercept and then use the slope rise over run to find a second point. All right, let's go ahead and look at some examples now. Now, I recommend watching some of the review material if you don't remember much about linear equations. These are concepts that we've gone over for at least 2 semesters, and so you can always go back and look at some other problems if you need help with this. All right, the first thing that we want to do, we have an example here. We want to find the equation of the line given the graph below, and then we're going to go ahead and try to find the x-intercept. So let's start by finding the equation. Okay, well, this one is going to be pretty easy in order to write it in slope-intercept form. The first thing that I want to do is I want to go ahead and identify my y-intercept. My y-intercept is where it crosses the y-axis. And so we have a y-intercept of 4. And remember, this is going to be our b value. So if we have our line in, or our slope-intercept form here, we can go ahead and plug in 4 for b. And then we just have to figure out our slope. You can do this one of two ways. You can go ahead and use your formula for slope and find another point on our line. So we want a nice point. I think that we have a nice point right here. And this point is, we are going 7 to the right, and 2 up. And so you can plug in your 0.04 and 7.2 in order to go ahead and calculate your slope. The other thing you can do is you can use rise over run. And so if we do rise over run, note that what we are doing here is we are going 2 down, and we are going 7 to the right. And so what we end up with is m equals negative 2 over 7. So if we plug that into our formula, we get y equals negative 2 over 7 x plus 4, and there is our equation. Okay, we want to find the x-intercept. Now here, it's not visible on our graph, but if we continue to the right, we can find it. Again, here we can do one of two things. For this problem, if you want, we can think using our slope. So if we go down another 2, I will be at 0. And we want to go another 7 to the right. And if we go another 7 to the right, we should end up at 14. So we should have an x-intercept. Remember that x-intercepts, we always go x, which is 14, comma y, which is 0. Now, as I mentioned, we can also do this algebraically. We can do this computationally. And so here, if we plug in 0 for y, we can then go ahead and solve for x. And so we can subtract 4 from both sides. We would generally divide by the coefficient, but because it is a fraction, I'm going to go ahead and multiply by the reciprocal. And if we multiply this straight across, we get 28, positive 28 over 2, and that is equal to 14. All right, that takes care of this example. Let's go ahead and see what else we got. The other thing that we're going to want to do is we're always wanting to use functions to represent real-life situations. A lot of situations in real life can be represented using linear functions. And so just a couple things that we want to review is, remember, x represents the independent variable or the input. When looking at word problems, remember that our slope, m, represents the rate at which f of x changes. For linear equations, we are looking for phrases like is increasing or decreasing. You should also see 2 units to indicate that the value of the slope is a change in the dependent variable over the change in the independent variable. When looking at real life situations, we like to use b to represent the initial value. And our function represents the dependent variable or the output. One of the new topics that we're going to look at in this section is linear equations are great for modeling real life situations, but they may have restrictions on them. And so we want to talk about interpolation versus extrapolation. Interpolation occurs when we estimate values between given data points. So for instance, if we're looking at something that's happening between 2010 and 2020, if we pick a number between there, we call it interpolation. Extrapolation occurs when we estimate for values that are not between the given data points. So for instance, again, if we're looking from 2010 to 2020, and I ask you to estimate for 2025, that is considered extrapolation. It's outside of my range. And the main thing that we want to see, or that we can see, is that interpolation is usually more accurate than extrapolation. A lot of these application problems, they'll only work for a certain amount of time before we have to adjust our formula, which we're not going to do in this class. All right, let's go ahead and look at an application problem. We have in 2011, daily activity users were about 460 million, and this number increased to 1 billion in 2015. We want to use the graph to find the equation of the line. All right, so the first thing that we have here is we do have 2 points. Notice here are years. Remember I said years was a good example of an independent variable, which we do see here. And so we have our years are going to be our x values, and our number of users is going to be our y values. All right, we want to find the equation of the line. So just a reminder, what we need here is we need a slope and a y-intercept. So the first thing we're going to do is we're going to find our slope. We want to go ahead and use our formula for slope in order to calculate this. We are going to subtract our y values. So we're going to do 1,000 minus 460 over 2015 minus 2011. If we subtract this, we get 540 over 4, and that is equal to 135. Now it does say find the equation of the line. We do have our slope and we have some points here. In general, we don't like going from the year 0. For instance, does it make any sense to talk about Facebook users in, biblical times? No. But this particular problem does not say when to start. And so we are going to have to start way back in biblical times. So from here, what we're going to do is we are going to use our point slope form. So I'm going to take my slope, and I'm going to take one of my points. I think I want to go with the 2015 and 1000. One thing to note is it doesn't matter. I encourage you to do this with the other point and then see if they match up, because they should. So if we plug this in, we get y minus 1000 equals 135 times x minus 2015. All right, if we go ahead and find the equation of our line, we do want it in slope-intercept form. We're going to go ahead and distribute. We get y minus 1000 equals 135x minus, if we multiply 135 times 2015, we get 2720225. We can add 1000 to both sides. And we get y equals 135 x minus 271,025. And that is going to be our equation. Okay, from here we want to go ahead and interpret the slope. And so our slope is 135, and we want to talk about what does this mean in the context of the problem. So remember that for slope we want increasing, decreasing. Is this increasing or decreasing? It is increasing. Well, what is increasing? If we go back and look at our application problem, we have Facebook's daily active users. So that's what we're looking at. The daily active users is increasing, because it's positive, by 135 what? And so remember, we do need to be careful about this, because we do have up here, remember, these are not just users, these are million users. And so we want to say something along the lines of 135 million users. And remember that we do want to include 2 units. So I've got my first ones. My second one is going to be per year. Okay, let's go ahead and look at example C and D. It says use the equation of the line to predict the daily active users in 2012. And so we're going to plug into our formula. Remember, X is the year, and so we are just going to plug in 2012 for X and then simplify this. So if we go ahead and compute this, I get an answer of 595. And remember that we do want to include our million, and then our unit, which is users. All right, and we want to repeat the process for 2019. in 2019, if we plug in 2019, we get 135 times 2019 minus that nastiness, and I get 1540. And again, users. All right, though we're technically not asked to find it, this first one, 2012, this is an example of interpolation. This is inside my range of values. The 2019 is somewhere over here, and this is an example of extrapolation. It's outside our range of values of 2011 to 2015. Okay, so 2019 might still be accurate, but for instance, 0 is outside of our range of values. That would be another example of extrapolation. And that one definitely doesn't make sense because in the year 0, there was no Facebook. And so it's not going to be accurate. All right, so that's what we kind of mean when we talk about finding our equations, evaluating our equations, interpreting slope, and a little bit of the interpolation and extrapolation. All right, that finishes off this video. In the next video, we're going to go ahead and look at some more examples.